So in this last video, we're going to talk about what's called literal equations. And these can be a little tricky. We did talk about them in in Algebra 1, but literal equations are equations that have more than one variable, okay? So they look a little strange, but the same rules that apply to regular equations where there's only one variable applies to equations where there is more than one variable. So we're going to begin with some easier ones. We're going to do some one-step ones first. So in this particular example, and a lot of times these come with these come from formulas, from geometry, from physics, anything like that. So in these one-step examples, we are going to be asked to solve for a variable other than what it is already solved for. So this one says to solve for h. Right now, it is solved for v. H is on this side. Now you have to tell and evaluate what is h doing with the other variables. Well, you should be able to see that there's no symbols in between, so that means that these are all being multiplied. So what is the opposite of multiplication? Well, it's division. So to cancel the L and the W off of that side so that h is alone, I'm going to divide by L and W. So that's going to make the LWs cancel, and I have V over LW equals H, and that's what I wanted. I wanted to solve for H. So H is equal to V over L times W. All right, now for the second one, it says solve for V, but right now it's solved for I. So where's the V at? Well, the V is in the numerator of a fraction, and a fraction means that it's being divided. So V is being divided by R. So what's the opposite of dividing by R? Well, you should remember that that means to multiply by R, or R over 1. So that's going to make the R's cancel, and I get Ri, or, well, I usually say it in alphabetical order, IR, and that equals V. V is equal to I times R. Now, the two-step ones get a little more trickier. Okay, they're not too bad, though. The two-step ones involve more than one variable, but there's also more than one operation to get the variable you want alone. So this one says to solve for F. F is here inside parentheses. Now, this formula currently is a way to change from Fahrenheit temperature to Celsius temperature. So when it asks me to solve for F, it's asking me to figure out, okay, F equals something, which means if we know the value of the Celsius, we can plug it into the new formula we're going to get here in a minute, and it's going to give you the Fahrenheit temperature, okay? So F is inside of parentheses, which is a very important idea. That means that this can be canceled right away from the beginning without ever distributing it, okay? So what do you have to do to make a fraction cancel? Well, you multiply by the reciprocal. That's going to make these cancel. We have 9/5 C equals F minus 32. Now that that fraction's gone, now I can separate the F and the 32. So if I'm trying to isolate the F, I'm going to add 32, and I get 9/5 C plus 32 equals F. This is actually what you would use to calculate if you're given a Celsius temperature. Multiply it by 9 over 5, add 32, and that'll give you roughly the Fahrenheit temperature. Okay? Now this next example is an example of the perimeter formula in geometry, and it asks us to solve for W. Well, this has to be isolated from adding and subtracting first. So I'm going to subtract 2L. So I get P minus 2L equals 2W. And then you should be able to see that now, in order for us to get the W alone, we have to cancel the multiplying by 2 with division. So I'm going to show you two ways of writing your answer. Clearly, once you divide, you're left with P minus 2L over 2 equals W, and I will accept that answer. However, there is a simpler way of doing this, because this long bar means that both terms are being divided by 2. Well, that doesn't change anything for the p because I don't know what p is. But it does change for this term. So if you have negative 2l divided by 2, the 2's are going to cancel and you're going to be left with p over 2 minus l. So p over 2 minus l is the answer when you're trying to solve for w. And then this last one for the two-step examples is involving solving for y. Now you've done this before. This is a linear equation that's in standard form. To convert it to slope-intercept, if you were asked to graph it, you would have to isolate the 4y. So to isolate the 4y, we're going to get rid of the 3x. And we have 4y equals negative 3x plus 12. So how do I get rid of the 4? Well, I would divide by 4. That's going to give me negative 3/4 x plus 3. Okay, so that helps you with the two-step ones. In the last video, we're going to do some more complicated ones.